In this video, we're going to be talking about vectors. A vector quantity is one that has a magnitude as well as a direction. Displacement, velocity, force, and acceleration are all examples of vector quantities. Scalar quantity is one where the direction doesn't matter, distance, speed. We can indicate the direction of a vector quantity using an arrow, and we can split any vector into a horizontal and vertical component. In vector terminology, we're going to use the letter I to represent one unit horizontally to the right, or in terms of compass directions, to the east, and J to represent one unit vertically upwards, or to the north. So let's say we have the vector U, which is 4 units east and 2 units north. See that it is to scale. So 4 of these I vectors will fit perfectly, and similarly 2 of the J vectors will fit perfectly along. As a result, this vector can be written as 4i plus 2j, and it can also be written in a column format too. If a vector is traveling leftwards or downwards, we can use negative numbers for the components. So for example, this one here, traveling to the left, means we're going to use -3 for the I, and since it's going upwards, we're going to use +1 for the J. Something what we might be asked to do is to calculate the magnitude of a vector. The magnitude is another word for the length of the diagonal, and it can be calculated using Pythagoras' theorem. Using the example that we had earlier, we had sides of 4 and 2, and if we go through the calculation, we'll find that u squared is equal to 20, and that u is root 20. When you type that in on the calculator, it will give you 2 root 5, which is approximately 4.47. We can also find the direction of a vector. This is mostly just a case of finding an angle using trigonometry, although there's a convention that we use. So something that you might remember in terms of angle conventions is bearings. We measure it from north, we go clockwise, and we write it as a 3-figure value. And what we do with vectors is we start from the I vector, and if the vector is in the positive quadrants at the top, we measure it anti-clockwise and denote it as a positive angle. If the vector is below the initial line, we write the direction as negative and measure it clockwise at 180 degrees. So let's put it into practice for our vector here, 4i plus 2j. It's above, we're going to measure this angle going anti-clockwise from the I line. If we do the inverse tan of 2/4, we'll get an angle of 26 degrees. We can just state the direction like that. Because forces are vector quantities, we're going to see some vector elements like the i's and j's appear in force questions. Let's say we've got this camel and we have these 2 forces acting on it, 10i minus 5j in the red and 7i plus 3j in the blue. If we want to find the resultant force, we're going to add the horizontal elements and vertical elements separately. Just a case of adding 10i and 7i to give 17, and to calculate 3j, take away 5j to give -2. Something that we might be asked to do from this is to find the magnitude and the direction of this resultant force. So our magnitude calculation is the same as earlier. It's just going to be Pythagoras. In this instance, we're going to get a value of 17.12 out. The direction calculation is also going to be similar to earlier, except this time we are underneath the original I line. So our direction should be indicated as a negative angle. So calculating the inverse tan gives us 6.7. We're going to write the direction as -6.7. Something else that we can do, if we're given a mass, we can rearrange the F equals ma equation to find the resultant acceleration. Let's say our camel weighs 10 kilograms. We can rearrange and have F divided by m is A. We'll divide our resultant force by 10, and we can get our acceleration, which in this instance is 1.7i equaling 0.2j. And once again, if we're asked to find the magnitude of that, we can use Pythagoras once more. Lovely.